Audio, si sentirà male come sempre. E se poi controlla un attimo che ci sia, diciamo, un attimo se funziona sto streaming su YouTube. Così chiunque vuole entrare senza passport, senza essere ammesso, a posto. Per la commissione rimaniamo con il fatto che ammetto io, però non vedo qual è il link di quella, diciamo, separata. La seconda quale sarebbe, scusa? Rimandano la WhatsApp così. Abbiamo acceso. Senti l'audio da quest'aula su YouTube tu per caso? Si sente l'audio mio che parlo? Ok, perfetto. Sì, sì. Perfetto, perfetto, grazie, grazie mille. Se non ci risentiamo vuol dire che va tutto bene. Ecco che va. Ok. Buonasera a tutti. Good afternoon to everyone. This is our last fall graduation session. My name is Luca Tardella. I'm going to introduce all the candidates. So let me just verify that they are all present at this point. So the first candidate is Dibodip Banerjee. Okay, you're here. I'm going to tell the title of the thesis and your supervisor later. So Francesca Casarano, Daniele D'Antoni, Camilla Lombardi, Leonardo Masci, Aria Falcondè, Clemente Recine, Dario Russo, Luca Urban, Gianmarco Ursini. Gianmarco? Okay, great. So we are here. You follow how many minutes we said? We agree with the 10, 12? Okay, so you all know, your candidates know that your time range is 10 to 12 minutes. Usually we don't stop abruptly the candidates, but we will try to make some signs in order to speed up your presentation and go to the conclusions. Otherwise, we are going to interrupt you. So the first candidate is Dibodip Banerjee. Dibodip, you can come here. Maybe you want to share. And Simone, where did you say the commission? Okay, this is your presentation. Is this the most recent one? Okay, so Dibodip is discussing a thesis, is presenting, is defending his thesis entitled Non-Parametric Model Regression for Directional Data. His supervisor was Paolo Brutti, and please, you have 10 to 12 minutes.
Okay. Good evening, everyone. As you know, my name is Dibodip Banerjee, and today is my presentation day. The topic I am going to discuss is non-parametric model regression for directional data. So, just to talk about the motivation, when we have dealt with audio data, video data, textual data, but in most of the cases, we have seen that the data comes from an Euclidean plane. However, this is not the case always. As you see in the picture here, it's a general example plot of an wing direction, and this data has some angular features as well. So the data may come from a directional plane. So this is a directional data. So we would like to address some challenges regarding directional data. The another aspect, as the topic says, regression. So when we talk about regression, most likely we talk about a mean regression or a standard regression, which essentially estimates the conditional mean of a data. Now, if you see this picture, sometimes their data is of more complex structure, and the normal mean regression may fail to catch the pattern of the data. So in those cases, or maybe if the error is heavy-tailed or skewed, in those cases also the mean regression is not a best choice or the most robust choice. So you could go for a modal regression. And the final motivation behind our work is we don't go for a parametric regression because that reduces the flexibility of our task. Essentially, we can go for a alternative which is called a non-parametric kernel regression. So based on that, we can play around more with the data and the regression system. So before we start formally, basic definition or basic introduction of directional data. Data may be of different manifolds, but we are particularly addressing a circular data here, so which is a subset of directional data. So now in terms of circular statistics, if we say the data is coming from a unit circle, we essentially call it a circular. And if we talk about a multivariate setup, essentially we don't call it a circle anymore. We call the data comes from a unit sphere. Then this is a spherical data. However, for this, we have considered univariate setup. So we will discuss a circular setup now onwards. So that's the, this is the gateway of our entire task. So when we talk about data and we talk about the distribution, and the von Mises distribution is the most familiar probability distribution in terms of directional statistics. This is essentially a circular form of standard normal regression. As you see in the PDF, there are two parameters. One is kappa, another one is mu. So the mu essentially is the mean of the distribution, and the kappa is called the concentration parameter. If we try to correlate it with a standard normal Gaussian distribution, then the role of the kappa is somewhat similar to the role of the variance. So I would like to, in the picture, I would like to focus on the red line and the blue line here. So you see for kappa, for a high value of kappa, the line jumps a lot. And when we reduce the value of kappa, then it turns to be a straight line. So however, this is some sort of, parameterization. So if we want to work on that, we have to do it predictively. So now we have in the motivation also, we have said we will do something related to a kernel regression. So we will try now introducing the kernel setup. So if we consider a sphere, the kernel and let's say theta1 to theta n is our random variables coming from a distribution, then the kernel will look somewhat like this, where the capital theta is our data and the small thetas which are coming is as our candidate values. And here you see the H is our bandwidth parameters. This distribution, this kernel format was introduced by Bai in the year 1988 as per our literature survey. And if we consider a circular setup, then this kind of circular setup, circular kernel was introduced by Taylor, where you see it's somewhat similar to, with the another one, but the first one was vector sum. Here, as we are taking a univariate case, we don't have a vector, rather we have a variable setup. So, and here also in the previous case, you see H is the bandwidth, and here kappa, as we mentioned in the PDF, this is also a bandwidth. And the property of these two is these two will be always strictly greater than 0, these are, when if you want to tune it, you have to tune it predictively. So this is another just a small intro example plot how the nature of the kernels varies if you vary the value of kappa. So for a high value of kappa, it fluctuates a lot. For a low value of kappa, it doesn't fluctuate, it starts smoothing. But that we cannot say which one is good or which one is bad, because it depends on case to case. So here we introduce our proposal for the regression, the modal regression. So as we have mentioned in our motivation for a standard regression, we introduce the conditional mean. However, here we are introducing the conditional mode. So the conditional distribution, and theta, here for this example, theta is our covariates, y is the response. And we can consider the conditional distribution in terms of the joint distribution of y and theta by the distribution of theta. So in this case, if we are talking about conditional setup, it is equivalent to talk about the joint distribution as well. So for our specific case study, the covariates coming from a circular setup, the response coming from a linear setup. So y belongs to R and theta belongs to angular parameter, angular space. And if we talk about the joint distribution, as we don't have any population distribution available, so we talk about the joint kernel density. So k of theta I minus theta, that's the kernel of our circular setup, is the covariates, and L of y minus y, that is the setup of the linear of the Gaussian kernel we have considered here. So the k is taken as von Mises, that's the directional, and as you see, L is taken as the Gaussian kernel. And in both the cases, kappa and h are the bandwidth parameters which is to be set. So if, as you see in the previous slide, essentially we are searching for the maximum value of y, argmax of y. So if we converted it, or if we transit to the joint kernel density, our search category remains the same. So in this case, what we can do is, if theta is our candidate value and capital theta is the large value, so we can go for a Taylor series expansion, and we can plug in the expression of the Taylor series which is coming into the small y, and then this will be our the final equation, which you can see this is our final likelihood equation, which can be maximized over the values of theta. We can do this because M doesn't have any proper parameterization. So in terms of a Taylor series, we can get a local parameterization of M, and then we can plug in and try to find out the estimates. So the last equation which you see in the screen is not a very easily derivable. So we employ the EM algorithm, and this will be this will be our expectation step, and the next task will be maximize in terms of or using this expectation step. So once we get the expectation term steps, we try to figure out the maximization step, and we can easily solve this. This has a this has a closed form solution. Because the y, the response variable, is having a Gaussian kernel. See, if we do not have a Gaussian kernel, for example, then we cannot have this sort of solution. We have to go for some other optimization technique based on EM. And the solution will be the explanation of the matrix is y will be our response variable, w is the diagonal elements of the expectation terms based on the values j equals to 1 to n, and omega is a matrix where the first column will be unit vector 1, and the second column will be based on the degree of the regression. So here we are considering p equals to 1, which is a local linear case. So we have only two columns, n cross 2 instead of n cross p. So the second column will be theta 1 minus capital theta 1 minus small theta, so and so forth up to theta n minus theta. So this is the setup of our regression. And then we are moving to some sort of experimental results. So as we have mentioned, we have to set a bandwidth parameters. So for that, we used k-fold cross-validation where the k equals to 5. So we divided the data set into 5 parts, where in each case, 4 parts were used for training. The final part was used for testing. And we check for which pair of bandwidths. Here we have two bandwidths. One is kappa, another is h. So for which pair of bandwidth, we have the least cross-validation value. So based on that, we have chosen a value. And you can see we have used 3 simulation data. So we'll go by this step by step. So in the simulation 1, the signal was 2 sin x, and we have used 3 types of error. So the main nature of the error is, in first 2 cases, you can see the error is symmetric about 0, and the final one, the gamma error, is a skewed error. And in each cases, we compared it with relative efficiency. So with the local polynomial case, and we can see for the symmetric case, the performance is somewhat similar. But when we move to a skewed symmetric case, skewed error case, then the model regression outperforms the standard mean regression. And this is just a result image what we have got from our task. And this is our second simulation data. We just changed the signal. Rest of the system familiarization is same. But in this case also, we see the model regression performs way better than the mean regression in each of the cases, in each of sample sizes and everything. And here we can, this picture is a bit more clear than the previous one. You can see that the red curve is the mode curve and the pink curve is the mean curve. So the mode regression closely following the true model curve, and the mean regression is closely following the true mean curve. Now, this is the simulation data 3. Here we are introducing a more complex pattern of the data. So this has multiple local modes essentially. And if you see the the pink line, which is falling right in between these two curves, because this is essentially catching the conditional mean of the data. But if we see the red curves in the panels, in the left panel, the red curve catches the upper local mode, and the right panel, the red curve is catching the another local mode. So we can say this was a problem, like we cannot catch both the local modes at a time. So this is because the EM algorithm is essentially a unimodal regression tool, but we can mitigate the problem because if we change the initial value, then we can catch different local modes. So if we get different solution from the initial value and we can merge them together, then we can catch all the local modes in the data, which you can see from the picture. And this is an application for a real practical data. This data was collected from an R package called NPSAR. So here you have seen there are the covariates are wind direction. There are 200 observations, and the response variable was wind speed. So here also you can see the modal curve closely follows the main pattern of the data. So when there is the low density, there is less density of the data points, it goes down, and as far as the increment of the density, it catches the flow of the data. And then we reach to the conclusions, as the proposal and the process was quite novel. As per our literature survey, there was only one task on directional data, which is a multimodal regression, nothing else. So we have figured out some future tasks, which was a bandwidth selection. We have taken only a k-fold cross-validation, but there are some other techniques that can be employed in directional setup. EM algorithm, as we have said, it is a unimodal regression tool essentially, but it can be extended to a multimodal setup. We have introduced a process which is applicable to univariate data, but we have the scope to extend it to a spherical case, not a circular linear, but a spherical linear. And finally, last but not the least, it's a different combinations. We have taken the covariates to be circular, response to be linear, but there are cases or data also where both the covariates and response are circular, and maybe the response is circular, the covariates is linear. So we didn't research on these two parts. We left it for the future results. So here I end my discussion. Thank you so much.
So let's thank the candidate. Let me open the discussion. If there is any question from the committee. Any questions? So it seems that it has been a very clear presentation. So thank you again for your presentation, and let's move to the next candidate.
Thank you so much.
So let me pass to the next candidate. She's Francesca Casarano. She's presenting a thesis under the supervision of Professor Massimo De Felice. And the title is Data Management for the Governance of Insurance Companies. You have the floor, you know how to do it? No, I can help you. Okay.
Good evening. I'm Francesca Casarano, and my thesis is about the data management for the governance of insurance companies. My thesis deals with the problem of data management, particularly the data quality, in compliance with the European and the Italian directives like Solvency II and the Regulation 38. In the quantitative aspects, it resumes an experience developed in practical work experience and work activities. When we talk about data, in particular in data science and in business world, we talk about data, but it's not enough to focus on data, but in the quality of the data, because the data in the insurance world is of primary importance, and you also push international supervisory authorities. In fact, there is a regulatory framework in the European view. We have Solvency II regulation, a prudential regulation that imposes processes to support the insurance company governance. In the Italian perspective, IVAS introduced the regulation 38 with provisions on corporate governance. In both the regulations and the directive, we have an important focus on data management and data quality. In the directive, in Article 86, it says that the data has to be accurate, appropriate, and complete in all the cycle and lifestyle of the data, like in all the process. In the Regulation 38, in the Article 14, there is a focus on data management process, in particular with the input and all the stages, and a focus with the overview also of the governance. So during my work, when I talk about data quality, I talk about all the relevant stages of the process, like the input, the local results, about the final results. So the work was carried on the data management process in non-life business. There are some important quantities and relevant quantities to be calculated. For example, the best estimate liabilities and the solvency capital requirement. Solvency capital requirement is a solvency capital required by the Solvency II regulation that I said before. And it is really important that each company has to update it annually. The architecture in an ET perspective that I used during my work as a database management system, a central server for orchestrating parallel and distributed computing tasks, and a processing unit for the parallel execution calculation engines. Here in this image, we can see the partial internal model of an insurance company. This is a partial internal model to calculate the solvency capital requirement in a bottom-up perspective, and it's a partial model because there is both standard formula and internal model. In light blue boxes, we can see the calculation logic of the standard formula, and in the red one, we use specific models for the evaluation of the risk classes and the technical specification for the elicitation of the probability distribution forecast, the PDF. One of the most important processes and ancillary process to compute the solvency capital requirement is the threshold for the large claims qualification. During my work, I also developed a procedure to calculate this threshold. And in this diagram that I did in a business process management notation, we can see that there are some phases. The first phase is about the data, so the input data and the management of the data. And here we have the data quality checks that we do on the data. And there is also a particular data that is the expert judgment. And in this case, we have a data manipulation, always with a data quality focus. There are some other phases about statistical analysis, and then but they are not compulsory, but the last two are obviously compulsory to select the thresholds. The programming language is R, an interface in .NET, and it uses parallel and distributed calculation system. One of the most important part of Solvency II directive is the Pillar 3. The Pillar 3 is about the information reports and the the need of each insurance company to be clear and to show constantly their situation. We can divide three main particular groups of information reports: the one for the organizational proceedings, the one for the board of directors, and the other for the supervisory authority. The first kind of report is like a documentation on analytical quantities. The second one is an higher level of granularity, so a full group reports for senior management and board of directors, and it meets the regulatory requirement. The last one is the report for the reports for the supervisory authority, and they are like to be sent annually or quarterly. Annually, we have the regular supervisory report or the ORSA report. Quarterly and annually, we have the quantitative reporting templates. This is an example of the solvency capital requirement component analysis. So a kind of an example for the board of director reports. It is divided by sector and also by line of business. So we have a division between life, non-life market, and going deeper about gross and net quantities, and the possibility to go to the drill down approach. So go deep to each quantity that we have calculated during the entire process. This is an example of the quantitative reporting template. In particular, it is the S18, the one for the best estimate on life. And it is written in a specific language because EIOPA, the supervisory authority of European insurance companies, required the extensible business reporting language to do another kind of data quality check when he received all the QRTs from the companies annually and quarterly. In the first column, there is the sum of the projected cash flows from the first year to the 31 and others. And it is really important always for the focus of the data in all the process that all the results in the quantitative reporting templates square each other. So we have some kind of different cell with particular code because they have to match each other. I want to conclude with a perspective overview and about machine learning use of machine learning techniques in the insurance companies and insurance world. In literature, we have a paper written by the professors De Felice and Morricone about claim watching and individual claim reserving using classification and regression trees. In this article, the application of Descartes is meet the specification of Italian regulation. It is about the method for the control of reserves and claims in the motor field. But in June 2022, also IVAS, the Italian supervisory authority, sent a letter to the market with a survey. And in this survey, there are some questions about the use of machine learning methodologies, both in a perspective of the use, the kind of methodologies, the security, but also about the relation with policyholders and customers. We can see that it is very important what the results that this questionnaire can give us, because it will be very important for every regulation that we have in future in this field.
Let me ask the committee if there are comments or questions. And if not, your presentation was very clear. So thank you for this. And let's thank Francesca again. So next candidate is Camilla Lombardi. No, sorry. It's I think it's I skipped Daniele D'Antoni. Sorry. Sorry, I don't want to raise some panic or mismatching the order.
Did you receive my presentation? Because I sent it with delay.
Okay,
But I
which account?
Yeah.
So I think if Georgia got it,
Okay.
we have it. So it's. You want to check?
No, I think it's the right one.
Okay, so let me make the control L.
Okay.
So I'm going to make the sign of 2 minutes if you want.
Ah. Okay.
So Daniele D'Antoni is presenting a thesis under the supervision of Professor Scardapane. And I think there's been some external help by Alessandro Nicolosi, Leonardo, and
Leonardo Lab, yes, and
Jerry Componi
Yeah.
from Sapienza University.
Yeah.
So I don't know if they're online. Let me see if they're online. Okay, so we thank them for the help and let's
we can start.
leave the room.
Okay, hi everyone, I'm Daniele D'Antoni, and in my work that I'm going to present today is about deep learning. More in particular, I'm going to test the robustness of the most recent deep neural networks against a novel adversarial technique in two different image domains, the RGB, the classical domain of colored images, and the infrared one. With my work, I'm going to prove essentially how far the vulnerability of these recent models as far by using this novel adversarial technique. And I also extend the experiment for the infrared domain. Despite its applicability in a real world, the infrared domain in the literature is usually underexplored. So it's interesting to see if there are differences between the two image domain. I also check if there is somehow a transferability property of the attack between the two image domain. And then I propose also 4 different solutions to counter this kind of attacks. Before going any further, I want to make you all understand what I'm talking about. So what is an adversarial example? Usually in the recent years, there are a lot of application of models that requires to collect data in a perfect way, in an accurate and reliable way. Let's think, for example, semi-autonomous driving systems or monitoring and surveillance systems that cannot make errors. So under this point of view, the adversarial example can be seen as a way to test the weaknesses of these models. The adversarial example can be of 2 types, the black box and the white box. The black box is the case where we have no knowledge about the model, and this is the real world, because when an attacker, let's say, craft an attack with its own technique, usually cannot have access to the API, the product that he wanted to attack. The white box instead is the version where we have a full knowledge about the model. So in that particular case, we are essentially trying to find which are the weaknesses of the model. Adversarial examples can be crafted from many kinds of data, text, audio, images, and graphs, and so on. And for my work, I use an adversarial technique called pixel that is based on a simple rearrangement of the pixels inside the image. Here we have an example of a successful attack of pixels. Here the image is essentially equal to the same. We have only 2 pixels mapped. I don't know if you see it, but there are 2 pixels mapped. This one under the roof and the one on the sky. And even mapping only 2 pixels, the models that I have used are full. So the classification is made by the model is wrong. Here I propose 2 different versions, as I said before, the black box and the white box that is called WITS. The black box pixel is based on a simple random search for the best pattern to fool the models. So essentially the algorithm takes the image, sample a random patch, and randomly map the pixels inside the random patch to the other location of the image. And it repeats this operation for all the restarts and save the best results for the next one, let's say. The algorithm will stop only if and only if the current best result that he gathered is already fooling the model, or in case it's finished the number of iterations, let's say. The white box, as I said, is a version that exploits the additional information. In this particular case, the additional information that exploits from the model is the gradient information that, let's say, measures the information, the importance of the pixels inside the image in this particular case. So we can say that by using this kind of information, it is possible to evaluate a probability distribution that will be used to map the pixel. So here, no more random search, but we take, for each iteration, we are going to map a specific number of pixels, where the source pixel that have to be mapped will be more likely, the one will be more likely sampled, the one that have the highest value of this probability distribution, while the one that are more likely to be sampled as pixel to be replaced will be the one with the lowest value of the gradient. In other words, we're essentially mapping the pixels, the most important pixels, to the place where they are the least important, let's say. Here I put the results. This rate of percentage represent the number of success, the rate of success of the attack that we have done. As we can see, most of the attacks have an accurate a success rate of 100%. And we can say that the infrared, with respect to the RGB case, suffers even more than the RGB case, the attacks. And so this shows the strength of the attack, but at the same time, the vulnerability of these models, because a simple mapping of few pixels is strong enough to fool those models. Overall, we can say that both the attacks are effective, but of course, Wixel, by exploiting additional information, are more accurate, and overall, of course, is even faster. But there is a limitation, the fact that we need to access to the model, and usually this does not happen. So the black box pixel has the advantages to does not require any additional information, but of course, by performing a random search, it can require minutes to craft a single attack. So far, we have seen that the infrared domain, such as the RGB, can be used, can suffer in the same way this particular mechanism. But it is possible to transfer the same successful pattern from one domain to the other. The answer is yes, but with some condition. Let's say in a black box scenario, this usually does not happen. The random search is not enough to guarantee a significant success rate. But when we can exploit the additional information, in this case, the gradient information, we can have an increase of the success rate up to 40%. This is an improvement, let's say, under this point of view. As I said, they also propose 4 different solutions to counter the vulnerability of those models in order to being able to overcome the attacks, but they can also can be applied to other types of adversarial generation technique. The 4 defenses that I tested and I propose are adversarial training, adversarial detection, mitigation through randomization, and the epigram defense. The first one is a variation of the classical standard approach. In the standard approach, the idea of the adversarial training is to train the model on adversarial examples and clean images, so that the model essentially learn how the attack are crafted and should being able to overcome them. But in our setup, Pixel, as we know, is expensive in terms of time and resources. So I propose a variation that is the fast adversarial version of the training, where we use a Wixel that is faster than black box pixel with one-shot configuration, where essentially we perform the mapping of pixel with only one start and iteration, and where the number of pixels to map will be a random value between 5 and 40% of the dimension of the images. From the result, we can see that the defense works pretty well, and the general robustness is improved because the average success rate is significantly reduced. Moreover, also we have an increase of queries. Here, the number of queries are interpreted as the number of times that we invoke, let's say, the model to test the intermediate result. And if we think about it, can be interpreted as a form of improvement of robustness, because essentially we are telling that to the model to invoke the model more time than the case where we do not defend it. So the increase of the queries is also another form of improvement of the robustness. The second defense is adversarial detection through filters. The main idea is to use a filter to the images to detect the adversarial examples, and it is based on the idea that usually clean images and filtered clean images should have more or less the same prediction, while in the case of adversarial example, this is not the case. The mechanism is very simple. We define a threshold value and a filter manipulation, and the defense essentially copy the input, filtered, and evaluate for both the inputs the vector of the score of the prediction and calculate the L1 norm of the difference that ranges between 0 and 2. So if this value exceeded the threshold, we can say that the image is an adversarial example, so we can reject it. Otherwise, we can classify it. Of course, dealing with the threshold value, we need to consider the fact that an higher threshold implies the fact that we have a less sensible detection mechanism. So we can have an higher value of adversarial examples that are not detected, while less value of the threshold implies a higher sensibility of the mechanism. But we need to accept the fact that some clean images can be rejected, let's say. For my experiments, I choose threshold values that are more near to 0 than 2, between 0.3 and 0.9, and I choose as a filter the medium filter and a variation of the medium filter for the high resolution images, because it is usually applied to smooth images that are perturbed using this particular attacks. The results here show the effectiveness of the attack. Here we have the success rate. For all the compilation, we have a success rate that is significantly reduced. And we have the advantage is that the defense is faster and does not require the additional training. So it's an improvement in terms of speed, let's say. The third defense is the mitigation through randomization. And it is based on the idea on applying operation of resizing and padding through filters in order to reduce the effect of the perturbation. So the mechanism takes the input images, enlarge it with random values, and apply the padding. Here, the padding is essentially applying 0 values to the matrix of numbers that define digitally the image. And once done that, the image is sent to the classifier. In this way, the effects should be reduced. Of course, we need to take into account the fact that slightly modify the image can also decrease the performances of the model. So we need to choose values that does not decrease too much the performances of the model. Here I plotted the average degradation of the accuracy for this model. And the maximum value is up to 2 percentage point. For the experiment, I choose a simple upsampling algorithm because it fits perfectly the idea of the defense. So we do not require any complex algorithm, let's say. And the padding values will be sampled in a ranges between 0 and 10. Also, yeah, we can say that this defense out of the trick that we have seen up to now is the one that works the best. And it has we have an additional point with the fact that we do not, it does not require to make any distinction between the image domain because essentially it applies the transformation on the image and not on the model. The last defense is adversarial perturbation elimination through generative models and exploits the generative model to create a copy of the input in order to remove that does not have the perturbation. So the idea is to train a generative model that is the capability of generate an image. I train them on the strongly perturbed image. And in order to make this model being able to craft an image that is the most similar possible to its clean version. Here we have an example. As we can see, the strongly perturbed images is essentially cleanup of all the perturbation. I train 2 models, one for each image domain, and evaluate, as before, the success rate. Also, this defense seems to be very effective. And moreover, more impressive are the fact that the generative models are trained only on one dataset, and then it is applied on other different images, but the defense still works. This because generative models usually does not require to look at the images once trained. This usually, in fact, it is usually applied on unsupervised learning. In conclusion, we can say that, yes, deep neural network, even the most recent, are vulnerable to this kind of perturbation, and the infrared domain seems to suffer even more this kind of mechanism. The transferability property are not so good, except for the case where we are exploiting additional information. And when we can exploit them, we can say that having access to the color information of the images, so starting from a successful attack in the colored domain, is better than starting in the infrared domain. Overall, we can say that all the defenses works pretty well. Here I plotted essentially the average success rate and the average defense rate that essentially gives a measure of the effectiveness of the defense. And overall, we can say that the infrared domain, even though is the one that suffers more the attacks is also the one that responds better to once the defense is applied. And overall, the 4 different defenses, the mitigation through randomization seems to be the one that performed the best out of the 4. And this is the end of my presentation.
Thank you, Daniele. We see the question from the committee. Any comment? No? Okay, so thank you, Daniele. So next candidate is Aria Falconde. Aria. Okay. So Aria is discussing a thesis under the supervision of Professor Scarlatani again, and we have here an international partner from Universidad de Barcelona, Sergio Escalera, and I don't think he's online. Okay, so his title is towards self-supervised gaze estimation. So we are all curious about knowing what it means.
So, hi everyone, my name is Arya Farfonde, and today I'm going to present my thesis, which is about TOR self-supervised gaze estimation. This was a joint work between Sapienza and Computer Vision Center of Spain, under the supervision of Professor Escalera and supervision of Cristina Palmero. So, gaze essentially reveals where a person is looking or focusing. And it's a strong nonverbal cue that shows people's interest, attention, and participation in social interactions, which has a wide variety of applications, such as driver attention estimation, or in marketplace, consumer attention detection, and so on. So a typical, like a supervised gaze estimation method is as follows. A CNN architecture takes as an input high-dimensional images, and it outputs low-dimensional gaze vectors. And we use a loss like L1 loss to train the network. And to enable this, in recent years, lots of data sets have been collected that contain wide variety of appearances, geometry, and so on. However, current systems suffer from performance degradation when it comes to new distribution due to the containing novel head poses, appearances, geometry, and illuminations. So a direct solution to this problem would be collecting more and more data, but it turns out that this is an unscalable process that requires controlled conditions and complicated setups, and also tedious camera calibration and subject recruitment. So as an alternative solution, we could leverage vast amount of unlabeled images on the internet in order to train a network using a pretext task, which learns useful information such that we can then transfer it to our downstream task using fine-tuning on using small-scale annotated images. So this is an overview of our method. In the first stage, we perform self-supervised pre-training using large-scale unlabeled face images. And in the second stage, we perform supervised fine-tuning using small-scale annotated images. So as the pretest task, we consider the following. So we take an image, we apply two random transformations like appearance and geometric transformation to the image to get two different views of the same image. And then we get the vector representation of those images using an encoder. And what we would like to do is to maximize agreement between these vector representations. So these two vector representations should be closer in the embedded space. In order to maximizing agreement between the vector representations, we consider SWAP, which is a state-of-the-art method for self-supervised learning, which is based on online clustering, which enforces consistency by first matching the vector representation with some centroids or prototypes, which are learnable, and then it outputs outputs the cluster assignment for that vector. So then we can perform a swap prediction problem. So the swap prediction problem, what it does is it performs cross prediction. So the idea is that if these two vector representations contain mutual information, it should be possible to predict the second cluster assignment from the first vector representation, and also first cluster assignment from the second vector representation. So such self-supervised approaches has some property like invariance. So this maximizing agreement enforces the encoder to be invariant to the applied image transformation. This has some nice property for tasks like image classification, where we would like to be invariant to, for example, horizontally flipping an image, the class stays the same. However, gaze estimation is a structured task. When you horizontally flip an image, the gaze label changes. So what we would like to achieve is to enforcing the encoder to be equivariant with respect to the image transformation, geometric transformation. And based on the definition of equivariance, as I said, our goal is to enforce the encoder to reflect the image transformation applied in image space in its output representation. So to achieve this, we propose SWAT, which stands for swapping affine transformations, which basically our goal here is to equalize these two vector representation in terms of affine information. And to achieve that, first we swap the transformation applied in image space, and then we apply them to the vectors using a feature transform layer, which I detail later. And then we maximize the agreement between the transform vector representation. So in this way, we are no longer enforcing the encoder to be invariant. Instead, we're enforcing it to be equivariant with respect to the geometric transformation. So here's the details of the feature transform layer. It takes as an input a vector representation and 2D affine matrix of the transformation. And it first changes the dimensionality of the vector representation, and then it performs matrix multiplication. Then we can get back our vector representation using vectorization, and it outputs the transformed vector. Here's our transformation catalog, which contains different appearance and geometric transformations, like changing the color, blurring, Gaussian nose, and as geometric transformation like horizontally flipping an image, rotation, scaling, and so on. So for the pre-training, we consider two large-scale data sets. One is specifically collected for gaze estimation, but we discard the labels. And we also use an uncurated data set, which is collected from internet, contains 1 million images. And then once we learned our unsupervised representation, we perform fine-tuning using L1 loss, using small-scale annotated images. And to do so, we first initialize our CNN backbone using the pre-trained base during pre-training, and then we perform the fine-tuning using the data set. So here's the results. First, we evaluated the quality of the unsupervised features, where we freeze the backbone and only train the multi-layer perceptron on the head. And we could see that SWAT pre-trained using the uncurated unlabeled data sets, VGG phase, achieves the best results. And more importantly, it outperforms ImageNet supervised features, which is widely used in current gaze estimation systems as initialization. Next, we evaluated our methods in the semi-supervised setting where only a portion of the data is available for fine-tuning. Here, the portion are 10% and 30%, and we could see that SWAT could achieve 1 degree less error, angular error, compared to the supervised baseline. We also compare our method with state-of-the-art and on 4 data sets, and we could see that SWAT outperforms the state-of-the-art methods on most of the data sets, but more importantly, it shows its superior performance in unrestricted data sets like this 360 and MPI phase with star, because these data sets are not restricted in terms of head poses, and we could see the potential of enforcing equivariance here. Next, to assess the generalizability of our method, we perform cross dataset evaluation, where we train on a dataset and evaluate it on another dataset. And here you could see that on all of the data, in all cases, SWAT outperforms the supervised baseline by large amount. Also, to quantify the equivariance, we propose this metric, which is based on definition of equivariance, which you could see that, so the lower the value, the better the method. And you could see that SWAT achieves lower values compared to SWAB, because SWAB is invariance with respect to the image transformations applied in image space. So on average, we achieve like close to like 25% improvement over the SWAB. So far, I reported the average gaze angular errors, but here you could see the performance of the methods in the whole range, gaze ranges, in degree, horizontal and vertical. And you could see that SWAT stays consistent in the whole range, while supervised gaze performs poorly in the regions that we have less data or extreme head poses or extreme gaze, gaze direction. These are the qualitative results and the estimated gaze vectors. And you can see that SWAT better matches the ground truth compared to the supervised case, even in extreme head pose cases. And also here we can see that in extreme illumination conditions, SWAT better matches the ground truth than the supervised case. So as a conclusion, we saw that SWAT can learn more informative representation compared to the other pre-training schemes, and it could achieve superior performances in low data regimes when only a portion of data is available. And this is important for gaze estimation because this means that we could recruit less subjects when we want to collect data. And also, we saw that it outperforms the state-of-the-art approaches and performs better in cross-data set settings. So we believe that SWAT could be used in real world using by leveraging large scale, freely available, unlabeled data on the internet in order to boost the performance of current gaze estimation systems. So a paper out of this work has been accepted to the British Machine Vision Conference, or BMVC for short. Thank you, everyone.
Well done. Thank you. So let me see if there are questions or comments from the committee. Okay, if not, again, very well done, and thank you for your clear presentation. Let me move to the next speaker. Okay, you can leave it here. Okay, thank you. So our next candidate is Camilla Lombardi. Camilla Lombardi is presenting a thesis under the supervision of Professor Pietro Brutti and with the external collaboration of Elena Pugliesi, KPMG company. And the title of the thesis is Process Mining, a new technique to improve P2P process. I don't know if it's called- Okay, so okay, I have that being set the title, so maybe you want to.
Can I use the?
Yes, you can,
PowerPoint?
sure.
Thanks.
So please. Or just present this.
So good afternoon to everyone. I'm Camilla Lombardi and I'm going to present my thesis on process mining. In particular, I would like to thank the process mining team in KPMG who supported me in this in my internship, and the professor Brutti, who was my advisor. In this brief presentation, I would like to give a brief description of what process mining is and on the project that we carried out on the purchase-to-pay process. Process mining is an innovative approach based on the direct and objective analysis of data, in particular transactional and log data, which is used now since the companies are able to store the data on IT systems and we can track all their flows. The main analysis that can be done with process mining are process analysis, compliance check, and process improvement. Process analysis is an analysis that aims at discovering the process. We can then identify which are the variants of all the different flows that the process has when it's executed, and we can also quantify the crossing time between the main activities that characterize the process. The compliance check is instead a comparison between the actual process and a target model that we can design, and this aims to the identifications of all the violations with respect to the process model, and also violations to the norms that a company may have to respect. Finally, there's the process improvement analysis, which is aims at identifying which are the activities that add value to the process and which are lead instead to a decay of the performance, and also identify which are the process steps where we can introduce some automation or corrective action in order to enhance the execution. In this project, the aim was to design a process mining app that aimed at the continuous monitoring of the purchase-to-pay process, and we focused on two main areas: the process discovery and the process announcement. The process discovery, since we wanted to know how the process was executed in reality, and the process announcement to identify which were the areas that present more criticalities and anomalies. Finally, the contribution to this project to my team, since I participated in the data extraction phase and also in the creation of views after a data cleaning and data preprocessing step, in which we obtained clean and complete data in order to base our analysis on them. I also helped my team in the development of analysis and indicators with the advanced data visualization components. The purchase-to-pay process is how an organization wants to buy raw materials and goods that they need to do business. In particular, in the upper part of the slide, we can see the idle flow that a purchase-to-pay process should have. So we should start with the purchase requisition item and continue with the transformation in a purchase order and record then a good receipt and finally the invoice receipt from the vendor. In the bottom part of the slide, we can see which are the main subtables in which the data is stored, and This because we use the SAP as our data source. Celonis is the tool that we used to carry out this analysis, and in particular is the software, it's the market leader of process mining tools, ranked by Gardner and others group. And I wanted to report the architecture since it is interesting because it shows all the different phases that we executed to perform the analysis. We started with the identification of where the data was stored, and in particular the data sources. So we I already said that was in SAP, and we then connected through appropriate connectors to SAP, and we extracted the tables that we were interested in. Then we proceeded with the data transformation phase, in which we create the main views that we needed to perform indicators and analysis. And these views were uploaded in the process data model, where we designed the relationships between the tables in order to link all the information that were necessary. Finally, there is the app development in the studio section, where we can design the app and by creating dashboards with analysis and indicators. Finally, there is the release of the app to the users in order that they can begin their process exploration analysis. The process data model is one of the fundamental steps of process mining, because in this we have to define which are the case table and the activity table. Process mining is founded on three main elements: the case ID, the activity ID, and the timestamp. The case ID is the minimum elements of detail that we want to analyze, while the activities are, of course, all the events that occur to this case, and the timestamp is the moment in which they occur. Of course, in the purchase to pay process, the case ID was represented by the number of the purchase order and the number of the purchase order item. In this designing the process data model is needed to create all the tables to have a complete. We followed on with the analysis, and we started with the which is the main analysis in process mining, thanks to which we can have a visualization of all the variants, which are the an order sequence of events that occur to the cases. From this slide, we can see that thanks to this visualization, we have a transparent view of which flow the case actually follow. And from here, we see that there are more than 5,000 variants, which means that the process is not so homogeneous. But at the same time, we see that the first three variants covered like the 45% of the cases. So we can say that it's not homogeneous, but most of the least frequent variants are related to very small number of cases. Another core analysis of process mining is conformance check, where we quantify the number of cases that are not conforming to the target model that we designed, and we can analyze the most frequent violations. The number of the percentage of cases conforming is 36%, and we can have a high number in July 2022, as we can see from the temporal trend. And we can see also the most frequent violations, one of which is that the vendors create the invoice before that the purchase order is released, which we have seen in the idle flow. It's exactly the opposite. By selecting the violations, we can do a detailed analysis and observe which are the vendors for which this situation happens and how we can improve this problem. Another core, very important analysis in process mining and process discovery is the quantification of the crossing times between the main activities. We see here that most of them actually have a low average throughput time, which means that the process is actually performing good. Well, the average throughput time, which has a high value, it's the creation of the purchase order and the record of the good receipt. Therefore, we can filter some of the outliers to identify which are the vendors which have this high throughput time, since they are since the relation these two activities do not depend only on the company but also on the vendors. We finally implemented the key risk indicators. For each indicator, we have a traffic light indicator, which aims to highlight immediately which indicators are at risk, low risk, or medium risks, in order to consider which have to be monitored. And we also have three levels of details. We have the indicators, but we also have specific analysis that we worked on in order to identify which are the criticalities. I'm presenting the three-way match, which aims at identifying the correct matchment of the orders. And we compare the purchase order, the invoice, and the good receipts on specific fields such as the price or the quantity. If there is a complete match, everything is going okay. Well, we can also highlight where there are no match or a partial match, and we can analyze them by visually stating which are the vendors related. Finally, we can say that the process mining is a very innovative technique since it's based on data, and this is thanks to the fact that the process mining bridges the gap between data science and process science. Process analysis was first based on time-consuming interviews that were characterized by the high level of subjectivity. But now with this data-driven approach, we can actually have a objectivity and an analysis on all the data and not just on a sample. Finally, we can also, after identifying the problems, we can make some improvements and some corrective actions in order to, and we can also check the effectiveness that this improvement have on the execution of the process. Thank you.
So thanks, Camilla, for your presentation. Interesting. So, discussion. If there are questions or comments from the committee. If not, I inform you that we are in the middle of our session. So let's thank Camilla Lombardi again for her work. And let me call on stage Leonardo Masci, who is discussing a thesis under the supervision of Professor Pierpaolo Brutti again, with the external help of Rowena Gallinacci from ACEA. And let me give you all the. Sì, vediamo, ci proviamo. Non so per ora dove lo possiamo mettere. Sarebbe molto bello, ma
Lo vediamo. Vabbè, se non è caso sono
non so se qui c'era forse le cose esterne. 30 secondi di tentativo sono da questa. Va bene. Questo di Vicenza. Okay, so now you have 1 minute less.
Yeah.
This is the bargain. Okay, let's start.
Thank you very much. Okay. Hello, everyone. This is my final thesis. It's called Safeguarding of Water Resources, Machine Learning to the Rescue. I worked on this project during my internship in ACEA, and I would like to take the opportunity to thank Rowena Gallinacci, which is my supervisor, and she's watching right now, and also Federico Clari for being here right now. The goal of the project is to calibrate the input of water in the supply distribution system, since ACEA is the water management company in the city of Rome and central Italy in general. So this is some data-driven decision-making that we're making, and we want to choose the amount of water to supply in the distribution system in order to maintain optimal pressure within it. So we define optimal pressure as a pressure that is high enough so that water can easily flow into any building in its reach, but also not so high that it would damage the tubes and so the physical network. We achieved this goal by building a forecasting model that can accurately predict the amount of water that is being withdrawn by the users each month in the area of interest. So for this specific release of the project, the area of interest is that of Auto2, which is the company in Financia that handles the water management in Rome and Lazio in general. We can see it in this map here. We will be working with the perimeter of the city of Rome. We take water demands of users from January 2019 to May 2022. We only take clients with stable contracts in that time for this release. So no new clients, no clients that cease their contracts before May of 2022. This leaves us with a parameter of over 270,000 plants, where plants are the physical locations where the water is being withdrawn by the users. Each plant has a meter attached to it, which is the object that keeps track of the amount of water that is being taken. Meters are read approximately every 100 days in this parameter. You can see that we have two types of meters that we will be working with. Some are online, which are the newest kind. These types of meters automatically send out readings to the company. But unfortunately, they are very new. They're still being installed. So only about 5% of total meters are online. Most of them are the analogical readers, which is what we're all used to. You can go and take the reading by yourself and send it to the company. But regardless, an operator will come and read it, as we said, approximately every 100 days. So we can see that for the area of Rome, most meters are read in January, May, and September of each year. Although every single month, we have at least 1,000 meter readings. So there are some challenges posed by the implementation of this model. First of all, we can see that the meters keep track of the amount of water that is being withdrawn cumulatively. So we can see in this plot here an example of the demands of a plant. We can see each dot represents a meter reading. In January of 2018, the meter read approximately 1,100 cubic meters of water withdrawn by the system. This number keeps going up and up until January of 2020, where we can see that this number reached approximately 1,300 cubic meters. Then this drops to zero as meter substitution happens. So the new meter starts counting again, starting from zero and going up. Moreover, next challenge is the high heterogeneity among users. The user base of Oceana in Rome includes, of course, domestic utilities, so households, but also apartment complexes. But we also have many commercial utilities. And in predicting future demands, it's important to have for it to be possible to highlight some trends. And since domestic utilities can have very different trends compared to commercial endeavors, this poses problem in developing the model. So how do we reach our goal given these challenges? Well, first of all, we have to compute linear monthly estimations for the consumptions of each user, starting from the cumulative values. We then want to tackle the problem of heterogeneity by grouping together users of similar categories. So we have different categories attached to each user. We have households, apartment complexes, and commercial endeavors. So we compute target distributions for each of these categories, which we will then use to recalibrate the linear estimations. We will go into greater detail as to why this is necessary. Once we have robust non-linear estimations for each user, we can obtain the total consumptions of the category. So a time series of the total consumptions of users in each category. And since we have this time series, we can then build the model for each category and finally put together those predictions to estimate the final water demand on the whole parameter. So we start with the linear estimations. Naturally, the easiest way to do this is to compute the difference in cumulative values between readings and to count the number of days in between readings. We can then compute their ratio to obtain daily linear estimations. We can see in this graph here, we have the same point as before. The yellow dots represent readings. So we have a reading in January of 2019, then again in May, and finally we will have a third one in September. We can compute the difference in cumulative values read in May compared to that of January, and we obtain a daily quota of 0.225 cubic meters per day. We can see that then that daily quota is different in the next period of time. We, of course, can then multiply this daily quota by the total number of days in each month to obtain the linear distribution of the consumptions in each month. This poses a problem. We can see here that we are estimating the same daily consumptions from, for example, from May to August, which is a little bit unreasonable. We would expect, for example, consumptions to go up in the summertime as temperatures get hotter and be lower in the wintertime. This is especially problematic in the case when the meter is not read for a very long time. The rule is not that they have to be read every 100 days. Sometimes they're not read for months and months, even 1 year. And of course, it would make the distribution not very robust to have linear estimation throughout the whole year. So for this reason, we compute target distributions for each category. So we do this by grouping together the consumptions of all the users in that category. And the idea behind this is that if a meter has not been read in a period of 6 months, we can exploit the readings of other meters in the same category to estimate what the consumption in that specific month should have been. So we can see here, of course, the graph is very zoomed in so that we can better appreciate the different trends. These are the apartment complexes, which do tend to stay pretty stable throughout time because of their size. We can see instead for the households, there are clearer trends. Consumptions go up in summertime and they stay low in the wintertime. And then again, for the commercial endeavors, we can see kind of like a similar seasonal pattern. Plus, we have some influence from COVID restrictions. So of course, during lockdown, consumptions go very low, and post-pandemic, they're still not quite back to the higher levels we have pre-pandemic. So we take these target distributions and we recalibrate the linear estimations to obtain non-linear estimations. And we can see in this small example here, the red dots represent meter readings. And again, the non-linear estimations, they're much more curvier than the previous ones, but they still interpol the values read upon meter readings, which of course is very important in ensuring a robust estimation. So now that we have all of our time series for each of the category, we can move on to modeling. We tried different types of models, including nonlinear ones, but the ones that did have the best results were part of the ARIMA family of model. We can see that for the commercial users, the SARIMAX model was the best performing one. S stands for seasonal, so because we expect seasonal patterns throughout the years, and the X stands for exogenous, so the external variables that can aid the prediction. You can see here that the exogenous variables in this case were all weather variables relating to the temperature, so the minimum average temperature throughout the months, and the average daily highest temperature and lowest temperature. This left us with a mean absolute percentage error of 0.020, which was well below the threshold set by the company of an error of around 5%. We then can see that for household and condominiums, the SARIMA model was the best performing one, so no exogenous variables were identified that could accurately aid the prediction. And this left us with errors of 0.012 and 0.027. We can see here graphs kind of showing this prediction. The test data are well within the 90% confidence bands. And we can also appreciate how the prediction does follow the trends shown by the actual data. So when consumptions are going down, the prediction does go down. And as consumption go up, the prediction follows that pattern. These are the commercial uses. You can then see the domestic use, the same thing. And finally, for condominiums, again, the actual test falls within the confidence bands and the prediction follows the trend. So finally, we can combine all of these predictions to obtain the final prediction. We can see this left us with mean absolute error of 0.021 and root mean square error of under 50,000, which considering that we are working with millions of cubic meters of water demands, this was considered very good by the company. And for this reason, we are using this model to predict future water demands in the area. Some next steps are the introduction of official codes, which are codes that allow us to further differentiate commercial utilities. So for example, we would be able to differentiate between a restaurant and a normal store, which of course we would expect them to have very different trends, and also deploying the model in other areas of Cyprum. And lastly, we were also able to exploit this model for two other goals. We used the nonlinear estimations to identify potential frauds. So we can see how user has been, how much water they've been using. And we can compare that with the average of what we would expect a similar user to use. And this way we can see, we can check if the meter maybe is not counting correctly, or if there could be potentially a fraud going on. And lastly, the computation of losses in the network. We do know how much water we are inputting in the distribution system. And thanks to this reconstruction, we can then find the difference and compute the losses that happen throughout the network, which of course is a great problem in water distribution and something that we're trying to tackle. So that was it. Thank you for your attention.
Okay, thank you very much for being in perfect time. So let me see if there are questions from the committee. Let me make a comment that it's been interesting to see this sort of challenging problem and practical problem to be somehow well addressed. So hope this is a sort of mutual exchange of favors with the company. So the company brings the challenge and we somehow bring our knowledge and our techniques, and then everybody should be happy.
Yes.
So if there are no more comments or questions, let's thank Leonardo again. Let's move to the next candidate, Clemente Recine. So Clemente Recine has, so he's going to discuss a thesis under the supervision of Professor Francesca Cuomo, the current president of the Data Science Master Program. She's not part of this committee, so she's not present here, but I think she's online now. I don't know if Francesca wants to say hello to the candidate. In any case.
Yes, I'm here.
Okay, so thank you, Francesca. So you have the maximum support today. And let me also mention the fact that Clement is one of our students in the Students Oral Program. So we're going to see what he has to tell today. So
Thank you very much.
Present your thesis slide.
Wait. Okay, so good evening to everyone. My name is Clemente Recine, and today I will present the industrial use case I've worked on with KPMG Italy on the use of machine learning for predictive maintenance in the automotive sector. So I would like to start by thanking Francesca Cuomo, Alberto Marocchino, and the entire KPMG team who supported me throughout this journey. So a quick overlook on the contents of this thesis. I will first start by introducing the use case and the value of predictive maintenance. Then I will highlight two major issues and their corresponding solutions. Finally, then the modeling choices and the results are presented. And finally, the contribution of this use case and the future work. So this thesis places itself in a proof of concept for a major player in the automotive industry, who asked us, on the one hand, to be able to predict vehicle failures, and on the other hand, to understand the reasons for such failures. This quest for machine failure prediction is commonly known as predictive maintenance, or PDM, which leverages artificial intelligence to make predictions and generates major business value, both on the side of cost reduction and on the side of customer satisfaction rates. The main contributions of this thesis is the innovative approach on how the data has been prepared and the focus on interpretability that goes against the reference academic literature. Now, this figure highlights the three maintenance strategies. There's reactive maintenance, which is just when a car breaks down and you go to the workshop to have it fixed. Then we have preventive maintenance, which is a time or kilometer interval maintenance type. And finally, predictive maintenance, which using the data predicts a possible failure and calls the vehicles to the workshop to prevent the failures from even happening. Now, I hope it is clear that PDM allows for cost optimization. And while there are no official statistics on the automotive sector, looking at the manufacturing sector, companies that use predictive maintenance increase their ROI by 10 times. So I've worked on sensor data coming from IoT devices placed on about 2,000 vehicles over a period of 3 years. This resulted in handling about 100 million records using Databricks, which is a data analytics platform that enables parallel computing. Also, details and information about the vehicle's configuration, as well as the historical failures, were provided. The figure on the slides highlights the fact that failure dates represented by the red dots are outside the vehicle sensor life, which are the thick black lines. So basically, many vehicles had to be excluded from the model just because we had no information about the vehicle's behavior around the failure dates. Some data enrichment has also been done. We have used an weather API to extract weather information, and we've also used KPMG signal repository. So as it is common in industrial use cases, some major issues have been identified. Two of them jump right to the eye by looking at this plot. In fact, we can see that there are long periods of time with no data transmission, and usually the average transmission days per month is just 6, which is not a lot. And also looking at the pink dots, we can see that a specific signal, the engine intake air temperature, is transmitted for a period of time, but then it just disappears, leaving place to new signals, for example, the engine load. Moreover, we have identified that vehicles with different configuration transmitted also different types of metrics. So major choices in selecting a subset of metrics that were available had to be done. Now, a quick insight into the comprehensive literature review brought forward for this thesis highlights that the most cited models in predictive maintenance literature are highly performant models like artificial neural networks and LSTMs. These models are extremely useful in a variety of use cases, but they usually lose their explainability. On the other hand, tree-based models that are often used only as comparison models or benchmark models, they provide by default the feature importance. Now, a famous definition of explainable artificial intelligence states that end users must be able to understand, trust, and manage the results of artificial intelligence systems. And feature importance is just a first step in understanding the model reasoning, and is currently available in a Power BI dashboard for the vehicle technicians to use to better understand this point. Again, from the literature review, that most common modeling solutions for predictive maintenance have been identified, and there are 3 of them. 1, predicting the remaining useful life of a vehicle. 2, predict if a vehicle will fail within a certain time frame. And 3, predict if a vehicle will fail in different time windows. While this last point will be part of a future work, the first 2 have been dealt with inside the thesis. An LSTM has been structured to predict the remaining useful life, but the results were not satisfying enough, so it will not be presented in this context. While using tree-based models for classification provided some very interesting results that we will soon see. But before looking at the results of the classification, we must see how the data has been prepared. In fact, we have taken each vehicle and we've aggregated the behavior of the vehicle considering a certain number of weeks preceding the failure date. This allowed not only to keep some kind of time reference, but also to work on a subset of data that is more manageable and but does not lose the information power about the vehicle behavior. Due to this data preparation, which we call the weekly buckets, a custom performance metric had to be defined. In fact, the model will output a failure probability for each input record. and so for each activity week of a vehicle. We will therefore say that a vehicle is prone to failure if this failure probability is higher than a certain threshold for at least 2 consecutive weeks. Now, the top 2 model performances are presented in the slide. We can clearly see that XGBoost allows for very interesting results. And it correctly predicts almost all the vehicles that did actually present failures and provides a reasonably low number of false positives, which are quite a costly matter in this use case. Also, looking at the permutated feature importance, which is just looking at the relevance of a feature if there is a rise or decrease in the feature importance by permutating its values, we have identified 4 major interesting groups of features. The warranty duration, then we have the engine performances and the vehicle configuration. So just by looking at the horsepower of the vehicle and obviously the usage of the engine, it has some relevance to the model. And finally, weather information. In fact, we've seen that vehicles subjected to consecutive harsh cold days were more prone to fail. So to conclude, in this thesis, we've dealt with the value of predictive maintenance, looking at the challenge of data democratization that goes against the reference academic literature. And finally, the modeling decision and the results have been presented. But what's next? So the project has been further financed by the automotive clients, not only to enhance its performances, but also to add some major interesting points. On the one hand, the feature importance on each vehicle will be structured. Then we will have to combine other prediction models. Just by looking at the fact that weather information was important, we will have to add a weather forecast model. And finally, we will have to structure more visual reports and analytics to build trust, not only towards the model, but also towards the entire approach. Because what is the reason of such a hard work if nobody will use it? And that's it for me. Thanks.
Thank you. Let me take 1 minute to see if Alberto Manocchino is among us today. Okay, so thank you, Alberto. I forgot mentioning that there was an external support by KPMG company, and so thanks for being with us. You can then join the committee for the final discussion of the grades. Okay, so thank you. So let me ask if there are questions or comments from the committee and from the external supervisor. Okay, if not, let's thank Clemente again. So let's move to the last 3 candidates. Dario Russo is on stage. Let me help Claudio. And so presentation. So Claudio is discussing a thesis under the supervision of Professor Francesco Battaglia and with the external collaboration of Enel, the person of Giulia Tagliaferri. Well, I don't know if she's here. She's online. Okay. So in any case, let's thank the company and Giulia for sharing this experience with us and with Dario. So Dario, please, you name your title.
Good evening. The title of the presentation is the machine learning approach to predict brand future behavior. So we don't need an introduction. We are trying to predict the future behavior of the brand by using machine learning approach and optimization process. The oil market is complex. It encompasses a lot of qualities of the product, exchanged with different kind of contracts by many players with different interests. The Brent, in particular, is a basket of high quality of oils extracted in the North Sea. The price of the Brent is computed as chaining the future contracts with the monthly future contracts. And instead of focusing on prices, we're going to focus on log returns in this first part because they present some interesting properties which are summarized in the so-called stylized facts. For example, the heavy tails distribution or no linear correlations between logs. The NL suggests some features which may help to predict the future oil price, the Brent price, using a minimum spanning tree, and using a correlation metric. It's possible to see that the features are divided in 3 groups. In the first group, there are features which are other commodities such as gold, power, and gas. Then there is the second group which contains features related with the US and European economy, and in the third group there are features related with the oil market and inventories. We also try to find any kind of linear relationship between the features and the log returns of the Brent. We found that there are some lags of the features which present this kind of correlation, but in the most of the cases, it's just a spurious correlation. We also try to find non-linear relationship using the transfer entropy, but it seems that only the inventory Aratot maybe cause the Brent log returns. We also decided to include the sentiment of the market in the analysis, which is retrieved from news on the web on a daily basis. Where we use 3 techniques through 3 different approaches: the bag of word approach, the Finbert approach, and the latent sentiment analysis, which does not directly extract the sentiment, but just features from the text. From the literature, we know that a news has a direct impact on the market, but then this impact can propagate over time. And for this reason, we want to take into account this behavior. And we apply an exponential weighted average with different spans to the sentiment extracted by the bag of word and the deep learning approach, which with the model Finbert. This strategy. So instead of using log return in our analysis, we use 2 new targets which hold the same properties of the log returns, but also are less noisy and should provide more information about the future behavior of the target. In particular, short term, they are both computed as the difference between the average, the key average future values and the actual value of the target. In particular, short-term target uses the key closest values from the actual value, from the actual price. Instead, the long-term target uses further prices. Okay. We also define a loss for this task, which we call the directional error loss, in which takes into account both the direction, the predicted direction and magnitude of the target, and gives more importance to the short target. It can be seen as a combination between a root mean square error and a directional accuracy. For the strategy, we use a sliding window, which is an alternative of the cross validation for time series. And so at each iteration, we keep a part of the training without taking into account the most older values, and the dimension of the windows is an hyperparameter. Instead, the target is always the next day value for both the long and short term target. We are going to use also models which are not autoregressive. So in order to take into account the past of our target series, we created two separate databases, one for the short term and one for the long term target, which concatenate the original features which we have already seen with a lagged version of the target. Okay, so the optimization is the last part of the work. We use the Optuna library, which is a library which is flexible in the definition of the hyperparameter space, and it allows the distributed optimization. We divide the optimization in two steps. In a first steps, the first part is called global optimization, and the second best model selection. This is why, because in the global optimization, in the first part, this is the whole pipeline for our in our research. We have two variable selection steps, and standard scalar, and then an application of linear PCA or kernel PCA, which is a hyperparameter, which one to choose. And finally a model. In the global optimization, we try to optimize all the parameters which are not in the model. And then after finding the best parameters, we run again another optimization, okay, in which we optimize, which we try to find the best model and its hyperparameters. From the metrics, it seems that the directional error is the best model is random forest, but comparing all the metrics, it seems that there is no huge differences between the performance of the models. In fact, all the models predict values which is close to the average value of the target, and it seems that it randomly predicts the direction of the target. Other conclusion is that we found that the best number of values to include in the average to compute the targets is only one, and that all the models perform better with a shortened target. So it may be possible for future steps to just use the log returns. We have some doubts about the usefulness of the extra features, because as we saw, the multivariate models do not show better performance than the univariate, such as ARIMA. Other possible future steps are to use a genetic optimization algorithms to avoid to use optimization processes which requires derivatives, and to try to use other loss objective function in the optimization. Thank you.
Thanks, Dario. For being time. So let me ask if there are questions from the floor. Let me mention that there has been here again some external support from Enel, Giulia Tagliaferri. I don't know if she's here or she's online. So let's thank Giulia. And so question from the committee. If not, let's thank Dario again. Next to the last is Luca Urban. Luca Urban is discussing thesis under the supervision of Professor Cinzia D'Araio. And Oh, sorry, this is the thesis. The presentation is, I think it's this one.
Yeah.
Okay. So look at 10 to 12 minutes. I'm going to tell you when 2 minutes are left. Okay.
Okay. Hi to all, I'm Luca Urban and I want to present my thesis. The title of my thesis is Assessing the Information Quality of Performance Model, a visual analytic approach. The main objective of my thesis, it was to create a visual analytics environment to test the information quality of performance model. This application has been developed with the European Tertiary Education Register project. This project is supported by the European Commission and collects information about 2,964 European higher education institutions. And information about these IAs are collected into 619 variables. And these variables refer to the basic characteristics like geographical information, number of students, number of graduate students, academic and non-academic staff, the revenues, incomes, and expenditures. The main application goal of my application is to automate the speed up of the exchange between the model setup that you can see in the domain analysis process and the visualization of that model. In this case, in this way, the user can retrieve much more knowledge and much more faster way about the ontology-based data integration about the data. In fact, we can see from the domain analysis process that the user must first gather the data about the application. Then he must apply some transformation on them. And then he can choose or to map the data and create the visualization about the main statistical properties of the data, or he can try to construct some models about that data, and then see the visualization of the results. In this way, he can gain knowledge about the data to recreate maybe a new data set, much more precise, or with much more precise transformation about that. Or he can try to do this type of work a number of times and gain much more knowledge about that. And my application tries to automatize this type of process that you can see also in the second image in the blue rectangle, in which it comprehends the second step and the third step. I created this application also because there is a lack in the state of the art and the literature. Because Erlinger in 2018 made a review on 667 software tools dedicated to data quality, but evidences several limitations about them. The first is that more than half of them work only with proprietary solutions. The second is that most of them lack implementation of important data quality dimensions that will be related precisely in the next slide, identified in the state of the art. And the third is that most of them do not support the comparability due to the way in which metrics are defined, and they also lack a user interaction with exploration capabilities supported by visualization for the data quality analysis. With our application, we tried to give to the user an application that is free to use for each analyst they want to use it, that has its center on the data quality dimension defined in the state of the art, and that give more interaction exploration capabilities to the user. The two most important theoretical bases about this application are the visual analytics and the data quality, in which their definition are presented into this slide. In fact, Cook in 2005 says that the visual analytics is the science of analytical reasoning supported by interactive visualization interfaces, and is composed by data analysis, the visualization, and the human-machine interaction. While Assistant in 2022 said that the quality is in essence understood as a degree to which data of interest satisfy the requirements is free of flaws, and is suited for the intended purpose. So the data quality is usually measured utilizing several criteria, which may differ in terms of assigning importance depending on the data end, the stakeholders, or the intended user.
And we can see that these criteria in the second image, in which are presented data quality dimension, presenting the state of the art, that are the dominance, the completeness, the accuracy, consistency, validity, uniqueness. Now we can switch to the application. In this first image, in this image, you can see all the tools that compose our application. And from them, the most important one are the ratio analysis, the anomaly check, and the consistency check. That will be also defined in the inside of this presentation. The first tool I want to present is the ratio analysis one. With this instrument, the user can calculate a ratio between two or more variables. And then the application will create first a Gauge plot on the main statistical properties of the ratio created. Then if the user chooses a geographical identification, it will also create a geographical map plot. And then it will also create a violin plot with a box plot inside of it, in which are also presented the outliers. Like in the example, as the third type of result. But if the user chooses a category variable in the top right selection column, it will also create a different type of rational of analysis, this type of analysis for each type of different category. The second component I want to present is the anomalies check. With the anomalies check, the user can calculate and see the outliers present in the data by applying the two-case fences method. To apply this type of tool, the user must first introduce the variable in which you want to calculate the outlier, and then to the constant value, in which meaning with all the formulas are present into the description of the tool. And then the application will return first a table, like you can see in the example, in which are presented all the number of outliers for each type of different category. So for the strong and for the weak outliers. Then the application will show a colored map plot, like in the ratio analysis, if the user chooses a geographical ID variable. And in the last table, it will show the data about the identified outliers. The last component I want to present is the consistency checks. With this component, the user can identify into a dataset the entities with potentially erroneous data. And the result that the consistency check component presents are divided into two parts. In the first part, I presented three tables. In the first, we show the metrics about the flag variables. And then in the second, we show the concentration of the highlighted entities, so with the one that the application flagged, by two types of different categories. That in the case I explained are the countries and the type of different category. In the second part of the result, the application will show the trend classification part, in which first show a table with the number of identified category and attribute for each type of different entity, in which the trend can be strong, undetermined, or weak. And then the application will show first a table in which are present the metrics with respect to the flagged institution previously, like previous. And then we show the tool will show a line plot with from which the user can see if the application did well in the trend percentage classification. Also in this image, you can see another example that I use when I use my application, the total revenue variable for the other data set. This type of application was also proposed to the students of Sapienza during their ISIS course project. From this image, you can see the two most important results of the survey we gave to the students at the end of this course. And then you can see from these two images that the system was easy to use and still being useful for the task we gave them during this course. The further development that will be applied on this application in the next month after my degree are that we'll be adding new type of visualization and charts in this application. Some analysis will be merged because they are similar scopes. I will give to the users also more models from which they can choose for the creation of all the plugged entities and the other one tools. And then we give also more customization for the result plot and explanation about the need of implementing the application. This application was also gathered to the RISIS dataset. That the databases of datasets include science and innovation dataset, but the application can be used with many types of different datasets. The only requirement is that it must be a time series ones. Some example of dataset can be medical data about the health of a specific person, the value returned by sensor instead of machines, financial accountability field indices, like for example, the stock market or balance indices for companies, also weather indices like pressure or humidity. And in conclusion, I want to give my special thanks to my professor that guided me into the implementation of this application, and also the other project team from which I worked during this experience. This work is also published on 4th of July, and you can see and free download them and read it. Thanks for the attention.
You're proud. Let me see a question from the committee.
If I may just a comment.
Yes, please, Cynthia.
It was really a pleasure, and I think it was the first time that Luca did really a nice job. He started to work 1 year ago, and this is why we received the publication of his thesis before the discussion. So I think this is.
So let's put full screen is
so this is
final.
nice job.
Okay, so thank you, Luca. Thank you again. Now, last but not least, our last candidate, Gianmarco Ursini. This is developed under the supervision of Professor Simone Scardapane and with some external supervision. So let me mention the contribution from Ellen, Francesco Beltri. I don't know if he's here or if he's online. In any case, let's thank Francesco for his support. Okay. Okay, so now it's
So good afternoon. Good afternoon to everybody. Yes, the name of my thesis is Generating and Written Text Images with GANs for Data Augmentation. After the name of the NL was the internship at which I participated. As Professor had said, my thesis advisor is Professor Simone Scardapane and the co-advisor Pier Francesco Veltri for ML. So basically, we will go to the introduction of the thesis, the description of the data, of the models and the experiments, and the results are carried out by this work. So basically, the aim of the thesis was to assess whether the NL optical character recognition model performances could benefit by a GAN-based data augmentation. I exploited different datasets. First, the EAM1, which is the benchmark database containing handwritten text images segmented at word level. Then LDS, which is an NL proprietary database containing handwritten text images depicting details about the customer, so dates, addresses, and so on. A small dataset that we collected among data science and NL colleagues, containing about 3,000 text images depicting words with special characters belonging to the Italian and Spanish alphabet, and 3 different textual corpuses, basically containing the most common words in English, Spanish, and Italian, exploited for the final generative stage. So let's introduce the models. Okay, the NL-OCI model is basically built by a convolutional module, a recurrent module, and a transcription module. It can exploit different decoding algorithms, like the best path or the word in search, and it is trained via the minimization of the connectionist temporal classification loss. So the IGAN is the first generative model I implemented. It basically exploits 5 different subnetworks, a style encoder, which is responsible to output a feature map only describing the embedding style, a generator, which is fed with trainable embeddings describing the query text that has to be generated, and the feature map describing the embedding style, which has to be exploited for the final generation, the discriminator, which has to tell apart fake from real images, the recognizer, which has to extract the textual content of the images, and the style identifier, which has to assess to which embedded style each image belongs to. So it exploits several losses. Of course, other than the standard adversarial loss, we want to enforce some of the behaviors of those submodules. For example, we want our generator, of course, to preserve the environment style information. We want that the generated images contain the actual test that has been fed to the generator. The style classifier then exploits standard percentage loss, the recognizer, the standard CPC loss, and the discriminator, the negative of the adversarial loss. The other model implemented is the embedding transformer. It basically exploits a vision transformer generator made by an encoder which has to output a feature map describing the embedding style of the fed images, and a decoder which is in charge of the actual generation of the synthetic data points. Then we have a discriminator, a recognizer, and a style classifier, which pretty much act like the one we saw before in the eigen setup. So denoting with the XI-S, the set of real images belonging to embedding style I, and with X tilde I, T, the set of generated images belonging to style I. Again, the style recognizer exploits the percentage loss, the recognizer CTC loss. Here, T of epsilon denotes the encoder of the vision transformer generator. So we want the output computed over the set of real images belonging to style I to be as close as possible to the output of the encoder computed over the generated images belonging to style I. Because as we say, the encoder is only responsible to output a feature map which has to describe the embedding style. And then we have a standard adversarial hinge loss. So I go on with the experiments. I fully retrained both the eigen and the embedding transformer on Amazon Web Service infrastructure. The training of the eigen took about 20 hours, while the training of the embedding transformer took about 120 hours. Each of the modules had to minimize their loss. So we can see, of course, that the generator loss is increasing. This is because basically the min-max problem faced by the GAN framework is a particular kind of bi-level optimization problem. So as soon as the discriminator gets better and better in dealing with its task, the generator loss increased by reflection. So already this picture tells us that the min-max game was not equally played in the eigen framework. The opposite happens in the embedding transformers. The constant trend of the generator and the discriminator loss tells us that the min-max game was equally played by both of those models. So I tested the two networks. I obtained a consistent result, if not better, in terms of FID scores with the one obtained in the presentation paper. Generating images with special characters, we can already see that they don't even satisfy the visual requirements of goodness. So I wanted to better dive in with this analysis, extracting the discriminator embeddings for three different sets of images. A real set of images, a generated set of images containing special characters, and a generated set of images without special characters. So we can see what we already saw before, basically in the eigenplot, which is the discriminator is almost perfectly able to tell apart fake from real images. In the embedding transformer, on the other hand, about 25% of the generated images without special characters are able to fool the discriminator, while the same doesn't happen for the generated images containing special characters. It basically means that none of the architecture are able to generate special characters text images, which appears to be realistic to the discriminator side. So I moved on with the dataset generation. I performed this augmentation process in an offline fashion, which is I exploited both of the architecture to generate a synthetic dataset, which is about the 400% the size of EM. Here comes the meaning of the suffix. And keeping all the embedding style, I then randomly sampled only a few of the images, basically to build a synthetic dataset being about the 20%, the 50%, and the same size of the EM1 in order to test a different level of augmentation. Okay, of course, I wanted to be sure that all the images, all the embedding styles seen in the synthetic dataset were actually unique, so that I carried on this style consistency analysis. Basically, I extracted 4 images for each embedding style seen in the synthetic dataset, flattened those images, and performed a 2D Disney projection. So we can see in this plot where each triplet of marker size, marker shape, and marker color uniquely identifies an embedding style, that the eigen generator is well capable to preserve the information about the style content, being each cluster of 4 images well isolated in this 2D space. the same can't be said for the embedding transformer generator. Indeed, even if few clusters can be identified, each embedding style looks way more similar than one to the other with respect to the one we see in the eigen, underlying the embedding transformer generator incapability to fully preserve the information about the embedding style at the generation time. Okay, I moved on with the OCR model training on top of all the different datasets with different level of augmentation. On the left, we have the training loss trends of the CTC loss, while on the right, the validation methods, which are the word accuracy and the character error rate. Something I found interesting is the fact that the training executed on top of fully generated datasets led to the steepest decrease of the training loss and the best improvement of the validation method. But we will come back to that later in the conclusion. So I used the OCR training on different datasets to compute the character error rate and the word accuracy value on two small test sets belonging to the EM and to the NLDS databases kept out of all the validation and training pipelines. And despite the fact that the EM database augmented with the embedding transformer synthetic dataset lead to the best character error rate on top of the NLDS, looking at the overall trend where the best results are highlighted in bold, we can say that the OCR model trained on realistic data achieves the best performance. So I draw different conclusions from this work. The first thing is that increasing the amount of training points containing special characters might effectively lead to a multi-language GANs generator, being able to generate language text images in an arbitrary language among the Italian, the Spanish, and the English one. We have to recall that the FID metric is the most common metric used in all the framework of handwritten text image generation, but this metric, due to the nature of its computation, has to be taken with a grain of salt. So we assume that the lack of performance improvement was basically due to the simple fact that the quality of the synthetic data points might simply not be enough to consider them as valuable OCR training points. Coming back to the evidence that we saw before, that the training executed on top of fully generated datasets led to the greatest overfitting of the model and to the worst performance on top of the datasets, this suggested to me that internal hidden patterns, which doesn't affect at all the textual content of the synthetic data points, which appear to be correct, might be exploited by the OCR model so to naively memorize the content of the synthetic data points, leading, of course, to a lower capability to generalize. Of course, also the concept drift issue has to be addressed when inferring over the NL database. Of course, none of the embedding style seen in EM will be seen in the NLDS database. And of course, the concept drift happens also at noise level. Even if NL asked me to don't report any sample belonging to the NLDS database for a privacy reason, it's possible to see that the data points contained in the NL database are way much more noisier than the one seen in EM, suggesting a future work already highlighted and appointed by the NLP team, the introduction of an image denoiser, which might actually and effectively reduce the amount of noise contained in the data points, so to possibly improve the performances of the OCR model. So these are the references about all I've been speaking about. Thank you for the kind attention.
Okay, so let me thank Gianmarco for the clear presentation and for the interesting topic. Let's receive the questions from the committee. Simone, Scadapane, supervisor, the other members. So if not, I'm going to thank Gianmarco again, and I'm going to say a couple of words before the final step of this graduation ceremony. So let's thank Gianmarco again. So it has been a very long and unusual graduation session with 10 candidates, although we should be somehow used to big data. So 10 for us, it's a sort of big data, too big data for all of us. So thank you for your patience and for having everything smooth. So we have been discussing a lot about a lot of topics, spheres, and water, oils, car purchases, and written text, and even gases. So let's thank again Acea, Enel, KPMG, Leonardo, and the other academic partner in Sapienza and the University of Barcelona. We have been hearing from Italian students as well, from Iran and India. So there's been a sort of very nice presentation session. So please give us 15 minutes for discussing the final grade. So we will gather here for the final ceremony, and the people in the committee move in the other room, which should be open. And let me try to see if there are also the external members, and if they are online, I hope they receive the link for the other reserved meeting. Siamo nell'aula 13. Cosa c'è la relatrice di
che l'aveva spenta. Dove sta?
Questa? Roberta?
Sembra tutto a posto.
Okay. Out of the darkness. Okay, so the 10 candidates, significant 10, can stand up here, okay?
Lì.
Questo non sai come funziona.
Avete fretta, no? A casa qualcosa iniziare a bere. Puzzini maledetti.
Okay, so I'm trying to. So we have to unmute this. Okay, that's fine. You can hear us if you want.
Vediamo qui. Carenza di zuccheri. Qualcuno dietro sta per svenire dal caldo, se volete un'iniezione di zuccheri ce l'abbiamo, Lascio qui casomai se c'è qualcuno timido.
Guarda, io non sono timido e accetto la tua.
C'ho neanche pochi tocchi, no, neanche un po'.
Okay, so
Al lato sinistro della trasmissione, casomai.
welcome back. This is now the final graduation ceremony. So I will call each candidate in alphabetical order. So let's start with the first candidate. So Devadip Banerjee. Devadip, by the power entrusted me by the rector, I admit you to the rank of those who hold the master's degree, laurea magistrale in data science, and I grant you all the rights and privileges pertaining to this degree. Your thesis work has been approved with a final mark of 107 out of 110. Okay, congratulations. Francesca Casarano. Okay, Francesca, by the power entrusted me by the rector, I admit you to the rank of those who hold the master's degree, laurea magistrale in data science, and I grant you all the rights and privileges pertaining to this degree. All your thesis work and defense has been approved with a final mark of 104 out of 110. Congratulations. Daniele D'Antoni, Daniele? Okay, by the power entrusted to me by the rector, I admit you to the rank of those who hold the master's degree, laurea magistrale in data science, and admit you, and I grant you all the rights and privileges pertaining to this degree. Your thesis work has been approved with a final mark of 110 out of 110. Congratulations. So Aria par conde. Aria, by the power entrusted to me by the rector, I admit you to the rank of those who hold the master degree, laurea magistrale in data science, and I grant you all the rights and privileges pertaining to this degree. Your thesis work and defense has been approved with a final mark of 108 out of 110. Congratulations. Camilla Lombardi. Camilla, by the power entrusted to me by the rector, I admit you to the rank of those who hold the master's degree, laurea magistrale in data science, and I grant you all the rights and privileges pertaining to this degree. Your thesis work and defense has been approved with a final mark of 105 out of 110. Congratulations. Leonardo Macci. Leonardo, by the power entrusted to me by the rector, I admit you to the rank of those who hold the master's degree, laurea magistrale in data science, and I grant you all the rights and privileges pertaining to this degree. Your thesis work and defense has been approved with a final mark of 105 out of 110. Congratulations. Clemente Recine. Clemente, by the power entrusted to me by the rector, I admit you to the rank of those who hold the master's degree, laurea magistrale in data science, and I grant you all the rights and privileges pertaining to this degree. Your thesis work and defense has been approved with a final mark of 110 with honors. So congratulations to Clemente. Dario Russo. Dario, by the power entrusted to me by the rector, I admit you to the rank of those who hold the master's degree, laurea magistrale in data science, and I grant you all the rights and privileges pertaining to this degree. Your thesis work and defense has been approved with a final mark of 110 with honors. Congratulations. Luca Urban. Luca, by the power entrusted to me by the rector, I admit you to the rank of those who hold the master's degree, laurea magistrale in data science, and I grant you all the rights and privileges pertaining to this degree. Your thesis work has been approved with a final mark of 100 out of 110. Congratulations. Last but not least, again, Gianmarco Ursini. Gianmarco, by the power entrusted to me by the rector, I admit you to the rank of those who hold the master's degree, laurea magistrale in data science, and I grant you all the rights and privileges pertaining to this degree. Your thesis work and defense has been appreciated and approved with a final mark of 110 with honors. So let me make a final big congratulations to all our 10 candidates and new master's degree of this stimulating master program. And I wish to thank all the friends and family who somehow put all their support, not only today, but during the 2 years of study. And I wish all of our students the best of luck for their future career. Okay, and I hope to see maybe one day back here to share your success in your life and in your career. Okay, so thank you, everyone. And now you can. So for the candidates, so yeah, now you can go and celebrate in some other way. So I hope you have to move outside from the building because we have to close everything. Yes. Yes, if you want. It was. Ciao Massimo, sei Massimo. Tornerò in Bravo Marco, hai avuto diciamo un sacco di complimenti nella parte che non hai sentito. Bravissimo.
Ah, sì, sì.
Sì, noi quando vuole noi io veramente se ce la faccia quest'anno, se no giuro che aggiunto un altro corso che insegna. L'anno scorso io stavo a Monaco, quest'anno però riuscire a fare quel percorso
Ciao Giorgia.
Vabbè,